I'm calling this properties of logarithms because that's all we're doing is talking about different properties of logarithms. I don't want to name all of them in the title of the lesson. That just becomes a lot. But yesterday we talked about the most important property of logarithms, which was how to rewrite it. So log base b of a equals c can be rewritten as b to the c power equals a. We talked about that yesterday. We talked a little bit about some of those properties that you might be able to see by just rewriting. But I want to talk more today about some, I'm going to call them algebraic properties. And there are 3 of them. And I call them algebraic properties because they use some algebra. And I'm going to look at these as, we'll look at it in more of a like algebraic kind of generic form, and then we'll throw some numbers in it to make sure we understand it. We'll do that for all 3, and then we're going to look at some examples of how to use them. So let's start with the first property, which is the product property. And the product property, much like its name says, means you're going to be dealing with some kind of a product within your logarithm. So maybe you have something that looks like this. Yeah. If you have something that looks like this, log base b of x plus the log base b of y, that can be rewritten as the log base b of x times y. Now, I used kind of the same notation as yesterday, where it can be rewritten in either form. You can either start with a single logarithm and write it as 2, or I can start with 2 logarithms and write it as 1. The idea is when we have 2 logarithms with the same base that are being added together, we can condense that into a single logarithm. And sometimes that helps us evaluate or solve an equation. Like that condensing piece can be really helpful. But the idea behind the condensing is we'll have the same base b, and then just the product of the 2 things in each of the logarithms. Like what are we taking the logarithm of in the first one? What are we taking the logarithm of in the second one? And we multiply those 2 things together. So numerically, if I were to put some numbers to this, I could say something like log base 2 of 7 plus log base 2 of 3 is the same as the log base 2 of 7 times 3. Now, I could multiply those together and get 21. Like, that's acceptable. But I just want to compare that to the generic and the one that actually has some numbers attached to it. So that's our product property. The second property will be a quotient property. And again, much like the name kind of implies, we're going to see some kind of a quotient happening here. So I'll start it the same way. We're going to have 2 logarithms with the same base, log base b of x, but this time we're going to subtract them, log base b of y. And then what happens with that is that we can rewrite that, again, as a single logarithm with the same base, but this time we're going to divide what was in the 2 logarithms. And the key to this is remembering that whatever the first logarithm was, that value x becomes the numerator of the new logarithm. And then whatever is in the second logarithm, or more importantly, what comes after the minus sign, is what goes in the denominator of that logarithm. So we've got the product property and the quotient property. The third one, let's put an example here with numbers, I guess. We did that on the last one as well. So something like the log base 2 of 7 minus the log base 2 of 3 can be rewritten as a logarithm with the same base of 2, where we would divide 7 by 3. Those are equivalent expressions. So that's what it might look like if we see it kind of, in a problem. All right, and the third one, which I think honestly becomes probably the one that in reality gets used the most, maybe not in this lesson necessarily, but you're going to see it used quite a lot. It's called the power property. And again, like its name sort of implies, we're going to have some kind of a power somewhere. So we may have something that looks like this. Y times the log base b of x. And that can be rewritten as the log base b of x raised to the y power. So what's happening here in either direction is that power, when we rewrite it in the other form, becomes a multiplier of the logarithm. You can almost imagine it sort of travels through the logarithm and goes from a power to a multiplier out in front, or from a multiplier to a power on the logarithm. So another property of logarithms, and that, like I said, I think this one is one that probably in reality gets used the most. So I might see something like, we'll stick with the same numbers here, 3 times the log base 2 of 7, and that can be rewritten as the log base 2 of 7 raised to the third power. So we're raising that 7 to the third power. So these are our three properties. So combined with what we did yesterday, I want to be able to use these in a lot of different ways. I want to be able to just use the properties in an algebraic sense, but I also want to maybe use them to do some evaluation. And I think I like the idea of starting with some evaluating. So let's start with some evaluating. That'll be my first example here. So we're going to say use the properties to evaluate. All right, so let's say I have the natural log of e to the fifth plus the natural log of e to the fifth. It's interesting, right? So let's use, what we talked about yesterday and what we talked about today. We're going to use all those properties in conjunction with each other to try to find out what this is going to be equal to. So my ultimate goal here is to find what is the value of that expression. And I don't want to touch my calculator. Okay, so we can do this completely without a calculator. We really haven't even talked about, other than me mentioning yesterday where the logarithm key is in the calculator, we really haven't talked about how to use the calculator yet. So I'm going to use my properties from today and then combine that with the properties from yesterday. So I'm going to start by using the power property. So I want to use the power property to rewrite this expression. And to do that, I'm going to take each of these powers that I see here and multiply, or use them as a multiplier in front of that logarithm. So I'm going to rewrite this as 5 times the natural log of e plus 5 times the natural log of e. And again, my ultimate goal is to figure out what this is equal to. Use the power property. So took it from a power to a multiplier. Now I could try to find a way to rewrite this as a single logarithm, and you could have done that initially and maybe gone from there, and that's not a big deal. There's not one path to get there. I want to discuss this logarithm or natural log of e. I want to think about what that is for a minute. Natural log of e. So yesterday we talked about some properties. Okay, we said we can look at something, a logarithm, and sort of decide what its value will be. So let's kind of think about this natural log of e for a minute as a side thought. So let's just put consider, because we want to take a break from our expression for a minute. The natural log of e, that can be rewritten, if you think of it in terms of what its base is, as the log base e of e. Right? That's what the natural log implies. when we have something that has the same base as it does what we're taking the logarithm of, do you remember what this logarithm would be equal to? And you can think about your properties from yesterday. It's 1. Yep. And we talked about how yesterday you get to that. You could rewrite that as e to some power equals e. And you get that expression is equal to 1. So going back to our original expression here, each of these are going to be 1. So what I really have is 5 times 1 plus 5 times 1. And again, trying to figure out what that is equal to. So what is that? Yeah, 5 plus 5 is just going to be 10. So without doing anything on the calculator, and maybe you initially look at that and you're like, I have no idea what natural log of e to the 5th plus natural log of e to the 5th is going to be. But when we use our properties and kind of break it down in pieces, we can evaluate that expression. I'm going to do a couple more evaluations, and then we'll go to... I used that A for that. And then we'll go to just some rewriting. So with B, let's do log base 3 of 18 minus log base 3 of 2. And once again, I want to know what this is, what the value of that expression is. Okay, so when we think just in general terms of logarithms, yesterday we said a logarithm itself is saying what power of this base gives me 18. That's the value of that logarithm. Well, I don't know about you, but trying to find a power of 3 that equals 18 is not an easy task. Same thing here. If I try to think about what power of 3 gives me 2, again, not an easy task. But I notice I've got these logarithms that are being subtracted from each other. They both have the same base. So I can go back up to my properties that we just discussed and use one of them to rewrite this as one logarithm. And I'm going to do that using the quotient property. So let's start with the quotient property here. To do that, I'm going to take those 2 logarithms and make them be one logarithm. And that one logarithm is going to have a base of 3. So log base 3. Now, because we're subtracting the logarithms, that means whatever's inside the logarithm has to be a fraction. First part, or the first logarithm, the 18, becomes the numerator. The second logarithm, that 2, becomes the denominator. So now I've got something that maybe makes a little more sense. We can simplify this at least. 18 divided by 2, that's something we can do. Yeah?
So we couldn't use the product properties if we were subtracting?
Right.
Okay.
Yep. Quotient for when you're subtracting, product for when you're adding. Yep. Good question. So this becomes log base 3 of 18 divided by 2. It's 9, right? And I want to know what that is. So if you need to rewrite this as an exponent, you did a lot of that last night. You would write it as 3 to some power equals 9. We're just trying to fill in the blanks here. What's the question mark going to be? Two. Yeah. What power of 3 gives you 9? The question mark is just 2. So just by using our properties to rewrite it in another form, I can take it from something where I have no idea what that expression is going to be without using a calculator to, oh, okay, that's not bad. It's just 2. All right, one more evaluating, and then I want to look at just some rewriting. So the rewriting kind of is similar to what you did last night, just lots of going back and forth between the forms. So let's say log base 7 of the 4th root of 7. At first glance, this doesn't look like I can apply any of my properties. But there's a really important rewrite that I can do here. And this, if you do go on to calculus later, what we're about to do is used pretty much on a daily basis in calculus. The ability to take something that's a root and rewrite it as a power. So what I mean by that is if I gave you, so I just want us to think about this for a minute. If I gave you something like the square root of x, that could be rewritten as x to the 1/2 power. If I gave you something like the cubed root of x, that can be rewritten as x to the 1/3 power. What if I said like the 5th root of x? How could that be written? Yep, perfect. Right? So a root is just an exponent in disguise. So I'm going to write that 4th root as a power. So the first thing I'm going to do is rewrite this as the log base 7 of 7 to the 1/4 power. Now I've got an exponent. Now I've got a power in my logarithm. So I can use my power rule, my power property here. So from there, I'll use the power property. Let me make myself some space here. So I'm going to use the power property. And I could write that as take that exponent, whatever it is, and it becomes a multiplier in front of your logarithm. So I end up with 1/4 times the log base 7 of 7. And then again, you might look at this and say, well, I still don't know what that is, because remember, our ultimate goal is to find out the value of this expression. But split it up. Consider the logarithm by itself for a minute. If you just look at this, log base 7 of 7, we know what that's going to be. 1. Log base 7 of 7. That's 1 again. So I have 1, but it's 1/4 times 1, which is just 1/4. And again, just using our properties, we can evaluate that expression and get an actual number that we can use. All right. So a couple of big important things that came from that is, watch your properties from yesterday. We're using that log base a of a equals 1 a lot. But also this idea that you can take a root and rewrite it in exponential form. That's really powerful for what you're doing now and what you'll do next year, especially. Because when you start getting to derivatives, you're having that ability is going to be really nice. All right, let's just do we'll just do a couple rewrites. So I'm just going to title this as rewrite, rewrite in another form. So I'm not going to use the words condense and expand like I will in the note or in the assignment tonight, only because I might mix them up here and do a condense and then expand. So I just want us to take it from one form and put it in another. Okay. So let's say I have something like, we'll just do a simple one to start. Log base 5 of 6x. Now I want to stop and consider what's happening in that logarithm, right? Because we got to be able to use one of our properties. This is saying 6 times x. We don't write the multiplication symbol in between. It's understood that when we have two things right next to each other like that, there's a multiplication symbol. So think of this as a logarithm that has a product going on. So we can use our product property. What we have is one logarithm. So if I go up to our properties here, what we have is one logarithm here. So we're given this guy. I want us to go to this, split it up into two logarithms. So we're going from one logarithm to two logarithms. I know it's the product property because I'm multiplying things together. So let's split it up into two logarithms. So I'm going to use the product property. Let me write that here. All right. So my product property tells me I can split up that one logarithm into two logarithms that have the same base. So that's what I start with. I'm going to start with the fact that I have two logarithms with the same base, and because I'm using the product property, I'm going to be adding those two logarithms together. And then I just fill each logarithm in with one part of the original product. So I take the 6, and that goes in the first logarithm, and I take the x, and that goes in the second logarithm. So we're splitting that product up into two different logarithms. This log base 5 of 6x has the same meaning and value as the two logarithms added together. Okay, so not too bad. what if I gave you, let's see, let's do the natural log of 5 minus the natural log of w. Natural log of 5 minus the natural log of w. So now I've got two logarithms that are being subtracted from each other. So if I go back up to my properties, two logarithms that are being subtracted from each other puts me in a quotient property. Two logarithms being subtracted. So this is the side that I have. I want to rewrite it in this form. So I have to take it from two logarithms to a single logarithm with the same base, and then write those two logarithms so that they're a quotient. So let me move that back down. It was not doing what I asked it to do. I'm going to take it from 2 logarithms to 1, and I'm going to do that using the quotient property here because I'm subtracting. Now, the logarithm that we write has to have the same base as the original logarithms, which means we're going to just use natural log. Because we're using the quotient property, I know that it's going to be a fraction inside the natural log. And then what goes inside the fraction, it's important that the first logarithm's value goes in the numerator, and the second logarithm value, or what follows the minus sign, goes in the denominator. So I would just have 5 divided by w. And that's it. So that's just a couple of relatively easy ones. I want to try 2 challenging ones, and then we'll wrap up. Kind of getting used to the properties a little bit with the evaluating. Let's try a couple of challenging rewrites. So if I gave you something like this, log base 3 of, and then this big old fraction, x squared times y cubed over w to the 4th. So this is one logarithm, but within that one logarithm, I see a whole bunch of things happening, right? I see I've got powers inside the logarithm. I've got exponents, 2, 3, and w. I've got a quotient. There's a fraction in there. But I also have a product, x squared times y cubed. I'm going to have to use all 3 of those properties, but I'm going to do those very slowly, very deliberately. I'm going to do one property at a time. If I try to do this all at once, it gets a little confusing. So the first thing I'm going to do is I'm going to address that quotient. So I'm going to get rid of my quotient by using the quotient property. Okay, so I'm taking it from one logarithm and I'm going to write it as 2 logarithms, addressing the quotient property. Now I know my 2 logarithms have to have the same base, and I'm going to be subtracting the second logarithm. So in the original expression, whatever's in the numerator is going to go with the first logarithm, and whatever's in the denominator will go with the second logarithm. So whatever's in the numerator, well, that is x squared y cubed. And then whatever's in the denominator is just y to the 4th. So I'm taking just the quotient out of the picture. So now I've got 2 logarithms that each have their own individual issues, right? The first one, there's a product, x squared times y cubed, but there's also those powers floating around. I always save the powers for last. So I'm going to address next the product. All right, so I'm going to split that product up that's in the first logarithm. So I would write this as the log base 3. I know I'm going to have 2 logarithms that when I add them together, or 2 logarithms with the same base that are going to be added together. I'm not going to do anything to that last logarithm. I'm just going to leave it as is. Okay, not changing that last one at all. And then I'm going to look at the fact that I've got x squared in my first logarithm, and I'll have y cubed in my second logarithm. I didn't give myself much space there, did I? All right, so let me just write those where they go. X squared with the first logarithm, y cubed with the second. So now I've addressed the product. all that's left are my exponents. So the last thing I want to address is the powers. So I will call this the power step. And we'll take each of those exponents and rewrite them as a multiplier. So each exponent that we see in all three of the logarithms and rewrite them as a multiplier. Yes?
So can you put all of them at the front, or do they have to go in front of the logarithm they're on?
Just in front of the logarithm that they're on.
Okay, so you can't put all of them in front.
No. No. And that can be, something that if you were to start this off by addressing the power property, you might end up in that situation. But, and I forgot to do that, put the 3, but it's only saying that 3 is a power of y, is saying I only multiply the log base 3 of y by 3, not all 3 logarithms by 3. And I'll show you here in a second. Let me rewrite this, and then I'll go up to the original problem. We can talk about when you would do that. But what I've got now is something that's in a completely different form than what I started with. If I go up here, and let's say that there was a power up here of 4, then you would write that. You could write it as 4 times the log base 3 of that whole thing, and then every time you write your log base 3, you would have a 4 in front of it.
Down onto the powers, right? So like since x is 2 is squared, you do 4 times 2 and then times the log of like,
Yeah. So you won't see that a lot, but it could happen. Yeah, that's a good question. Okay, let's go the opposite direction. So let's say that I give you the expanded form of it. So something like this. 4 times the log base 6 of x plus 3 times the log base 6 of y minus 2 minus 2 times the log base 6 of w.
Wait, can you scroll back up
Yep.
a little bit?
All right, so we missed the 3 on that log base 3 of w. Okay, so let's take a totally expanded form and try to condense it. So this is what it's going to ask you to do. It's going to take from multiple logarithms, and we're going to try to write it as a single logarithm. So we ended with the power property going the other direction. I always then start with the power property if I'm trying to go to a more condensed form of that logarithm. So I'm going to start by taking each of these multiples of the logarithms and writing them as powers of whatever's inside the logarithm. So that's my first step. Let's use that power property. And that's all I'm going to do. Okay, we're not going to try to condense it into one logarithm or anything at this point. We're just taking it in baby steps here. So I would have log base 6 of x to the 4th plus log base 6 of y minus 2, that whole quantity squared, and then minus log base 6 of w squared. Now, I'm very intentional about this. I take it 2 logarithms at a time because if I try to do all 3, I'm probably going to make a mistake. So I'm going to start from left to right and work on combining 2 logarithms at a time. All right, so I'm going to combine those 2 logarithms. What I notice is that they are being added together, which to me communicates that I have to use the the product property here. So my product property says I can rewrite those as one logarithm where I'm going to multiply what was inside. So x to the 4th times y minus 2 cubed. Now, if you would like, you can put some extra brackets around that just to sort of say, hey, that's when that logarithm ends. Notice I did not change anything with the last logarithm. I'm doing this 2 at a time. Otherwise, you're bound to make a mistake. So the first 2 combine using the product property. Well, now I have 2 logarithms, right? I have a log base 6 and a log base 6. That's just 2 logarithms. I can combine those. I notice that in between the 2 logarithms, there is a subtraction sign. That means I'm going to have to use the quotient property here to combine them. Now, my quotient property says I can take 2 logarithms with the same base and rewrite them as a single logarithm with the same base as the original 2. So log base 6 of, and now we're going to end up with a fraction here. So that fraction takes whatever is in the first logarithm this entire expression, puts it in the numerator. Whatever's in the second logarithm, and puts it in the denominator. So I'm going to have in the numerator x to the fourth times y minus 2 cubed. And in the denominator, I'm just going to have w squared. Now, if that bothers you, it looks really messy, just like I did in the one above, just put some brackets around it to sort of indicate that that whole thing is what's inside our logarithm. So we should be able to go from either form to the other. Generally, it's going to be more powerful to go from many logarithms to one, but there are times when we would need to maybe go to multiple. Any questions? Yeah.
So if you went in different